Okay, here we go. This is limits day 3, determining one-sided limits. If there's any edits or anything in this video, it's because I've probably had to pause and cough a bunch. So hopefully you can hear me okay. A little bit different setup today and don't have to worry about some fancy, crazy stylus. So determining one-sided limits. So last week, Thursday and Friday, we focused on just this last type of limit, where you're approaching a specific number. And for some of those problems, we made a table. We looked at whether our y values were approaching the same number from the left and from the right. And those two things had to match in order for the limit to exist at a certain number. So here we're just we're cutting that process in half basically. We're either approaching x from the left side or from the right side. So the notation here, if we're approaching from the lower or left side, we can see that in the limit, the number that we're approaching is going to have a little negative. It looks like a negative exponent, but it's just to denote that we're approaching that from the left. And then if we're approaching from the upper or the right side, then we have the positive. Okay, so negative means approaching from the left, positive means approaching from the right. And then no symbol is like what we talked about last week, that's the two-sided limit. All right, whoever's running our video and filling in as our guest teacher today, if I'm going too fast, just kindly ask them to pause the video. All right, so our first example, determining the one-sided limit. And we can still use those same strategies as last week. So for this, we can't use direct substitution. If we plug 3 in here for x, we're going to be dividing by 0, so that's not an option. But if we look at the numerator, x squared minus 9 is factorable. So we could write this as x plus 3, x minus 3, and then over x minus 3. So then our factors on top and bottom, the x minus 3's, will cancel out. So what that leaves us with is this x plus 3 here. And so now we can use direct substitution, plug in our positive 3, and we just have 3 plus 3. So the limit as x approaches 3 from the left side is going to be 6. Same exact process as last week. No changes, even though it's technically a different type of problem approaching from the left, we can still go about it the same way. All right. So just to kind of compare that a little bit more, we have 3 problems here. It's the same function, it's 4 over x, but we're approaching from not approaching from all 3 directions, but we have all 3 different types of limits on this problem. Give you a minute to write that down. So this first one up here in the top left, it says x is approaching 0. It's got the little negative, so from the left, let's go and label all of these. This one's got the positive, so we're approaching that from the right. And then this one, no symbol, so two-sided limit. Okay, so as we approach from the left side, we would be basically coming from the negatives, right? Any numbers to the left of 0 for the x would be negative numbers. So we can make a table on this, a little quick chart. And let's say we were to plug in negative 0.01 as our x value. And then I think I'm going to plug in 2 numbers here. So I'm going to go negative 0.01, and then we'll go negative 0.001. We'll kind of see the trend between those two. So with the first one, 4 divided by, I can't really see my screen to tell if you can actually read the numbers on the calculator. Oh, it looks like you can. So 4 divided by negative 0.01 is negative 400. And if we increase the number of zeros on that decimal, basically increases the number of zeros in our answer. So if we're dividing by an even smaller number, we're going to get an even larger answer. I say larger, meaning further away from zero. Technically, we're getting smaller, if we're heading in the negatives, but further away from zero on that. So negative 4,000 is the next value. As we keep getting closer and closer to zero, here, this number that we can't plug in, so we don't actually get an answer. But as we keep heading towards zero, these numbers are just going to get further away from zero, headed towards negative infinity. So this is our first infinite limit that I think we've seen so far. But this function is headed towards negative infinity as our x approaches zero from the left. Now, for this right side, let's just go back to the table and plug in those numbers, but with positives. So positive 0.01, positive 0.001. I'm not going to use a calculator because I know what the answers are. It's just right over here, right? It's going to be the same numbers, but positive. So this is positive 400, positive 4,000. So as we approach that x value from the right, our numbers are getting increasingly larger in the positive direction. So they're headed away from zero. They just continue to increase, and they're headed towards positive infinity. All right, and this is where we can kind of get away with using infinity as an answer, right? A function can never equal infinity. Infinity is not really a number, but the limit can be infinity because the limit is what we are approaching. It's not ever what we actually equal, right? So we're approaching infinity as x approaches zero from the right. So now for a two-sided limit, both of these numbers here would have to be the same in order to get a two-sided limit. Same thing that we talked about last week, right? If those two sides don't match, if these two numbers in the table don't match, then we don't have a limit. So the limit for this does not exist. Does not exist. They have to be approaching the same exact thing. Yes, they're both infinite, but one's positive, one's negative. So headed towards opposite infinities. Okay, let's check out this next one. All right, so we're finding the limit as y approaches negative 5 from the left side. We have that little negative in there. Hopefully you guys can see that okay in the video. But approaching negative 5 from the left of 1 over square root negative y minus 5. Now direct substitution is not going to work here because actually, it wouldn't work because we'd be dividing by 0. I was thinking that we'd be getting stuck because we're taking the square root of a negative. That's not the issue here. It's that we end up with 0 in the denominator. But we'll come back to that square root of a negative idea in a moment. So with this, if we were to make another chart, approaching negative 5 from the left, we'd want to plug in something like negative 5. Oops, got my decimal in the wrong spot there. Ignore that decimal. Negative 5.01. Negative 5.001. Let's see if we get a trend on this. So I have 1 divided by the square root of negative. I need some parentheses here. Negative 5.01 minus 5. Okay, notice the parentheses there. I'm just making sure that all of that is inside that square root on the bottom. Okay, so it looks like we're good. Let's see, the answer is 10. And then I'm just going to go back and edit that. I'm going to insert another 0. Hit second, delete. That allows you to insert numbers on an entry and instead of deleting and overwriting. Second and delete. Let me insert that extra 0. We got 31.6. Okay, well, that's different than 10. And not really like closely related to 10 at all. if you get something like that and it's not really sure, you're not really clear what it's headed towards, you can keep going. But these numbers are just going to continuously get larger, and they're headed up towards positive infinity. And now I want to show you the graph on this one. It's kind of interesting. We've got 1 divided by the square root negative, just replacing y with x, negative x minus 5. And then I'm going to reset my window. I don't know what my settings are at right now, just we see the picture. So that's what it looks like. Just this little tail over here on the left side. I'm going to change the window settings a little bit, kind of zoom in on that spot. Actually, let's just use the zoom in feature, and we'll scroll over here, and hopefully it shows us a good picture. So I'm going to kind of focus that zoom in on negative 5. That got me a little closer than I would have liked, but basically this graph is getting, as soon as it gets close to that negative 5 here, it starts shooting up towards infinity. Now, we already kind of saw that in the table, but the more interesting part here is what's happening on the right of negative 5, because nothing's happening. There is no function at all. If you were to try to plug in a number greater than negative 5 into this function, let's say I plug in negative 4. What I'm going to end up with is the square root of negative 9. And I can't take the square root. No, wait, is that right? Yes. Oh, I see. I missed a negative. Man, every one of these videos just guarantees I'm going to miss a negative somewhere, or a positive. So negative 4 makes positive 4, minus 5. We're actually taking the square root of negative 1. Ultimately, it doesn't matter if it's negative 1 or negative 9, though. We still can't take the square root of that negative. So anything on the right side of negative 5 is not going to have an answer. So the right-sided limit does not exist. The two-sided limit does not exist. But the left-sided limit is approaching, or is equal to, infinity. Okay, it actually only has a left-sided limit. You'll also see them called left-handed or right-handed limits too. It means the same thing. Doesn't mean you have to write with your left hand or anything like that. All right, still got the bad jokes. Okay, then I think, as long as I copied everything, did I miss? Let me check my notes here. Was that only 2 problems we had? No, I've missed a bunch of pages of my print off. That's all right. We can make this work. Not letting you off that easy. We're only 12 minutes in here. Come on, we gotta go at least twice that time. So next set of problems. The limit as x approaches 0, it's the left-sided limit approaching from the left, of absolute value of x over x. And we're going to do some comparison again on this one. We're going to find the left-sided limit, the right-sided limit, and the two-sided. Okay, so same function between those three. Absolute value of x over x from the left, from the right, and the two-sided. Okay, we're going to set up a table. And let's see, we're approaching 0. We can, let's just plug in negative point. Let's see, last week we were getting pretty close when we were making these tables. So let's just go with that same kind of pattern we had last week. We'll start with negative 0.001 for the left side, positive 0.001 for the right. And again, if whatever numbers you pick doesn't seem to give you a clear picture of what you're approaching, plug in more values. It shouldn't take you too long to do that, and it can confirm that you're headed towards a specific number or not. So I don't need the calculator on this. For evaluating this, if I plug in negative 0.001 for x, the absolute value just makes it positive, and then I'm dividing by itself. but the bottom's going to stay negative. So I'm dividing a positive number by a negative number. It's the same number on top and bottom, so this is going to be -1. On the right side, 0.001, when I plug that in, the absolute value is still positive, but the denominator is also positive. So positive divided by a positive is going to be +1. Now notice it doesn't actually matter what number goes in here, -52, -70, whatever. You're going to get the same number on top and bottom. Top is always going to be positive, bottom will always be negative. For the right side, same number top and bottom, but both positives. So approaching from the left of 0, your number is, or your function is approaching -1. Approaching x from the right side, the function is approaching +1. And since those numbers don't match, the two-sided limit does not exist. Okay. Next up, we have the limit as x approaches 2 of the square root 2 minus x. The limit as x approaches 2. So first one was from the right, this one's from the left. Mixing up the order on you here. Trying to catch you off guard. Doesn't really work if I tell you about it though. Limit as x approaches 2 of our same function. So again, the two one-sided limits and then the two-sided limit. So let's plug in some numbers here and let's see what happens. So from the right side, pause here for a second, give you a chance to write some of that down. So from the right side, if I plug in something greater than 2, I've got square root 2 minus, let's go 3. 2 minus 3. Go ahead and take out your calculator if you need to. You got -1. Taking the square root of that does not give us an answer. So anything greater than 2 will result in us taking the square root of a negative. So the right-sided limit does not exist. Left-sided limit, we should get some numbers here. If we subtract a smaller number, it's going to be positive, so that's fine. And so let's try square root 2 minus, let's just go 1.9. 2 minus 1.9 would be 0.1. And that's going to be a pretty small number if we take the square root, but let's, I'm gonna jump ahead here and let's go ahead and plug in the next number, 1.99, and then we are taking the square root of 0.01. Okay, how to make a quick edit there. So let's see, I was saying square root of 0.1, square root of 0.01. Those square roots, or the number inside the square root, is just going to continuously get smaller and smaller. If you take the square root of a smaller and smaller number, then your answers get smaller and smaller. So these answers are going down. We are headed towards 0. Okay, that's another one that I don't know that we've seen up to this point, headed towards 0. Now 0 is just a number, but sometimes it's harder to identify that you're headed towards 0. You know, if you're headed towards 2, you can see, oh, okay, 1.999, or okay, we're getting closer to 2. And that goes for either end, right? Maybe it's 2.0001. Okay, yes, we're headed towards 2. With 0, you got to pay a little bit more attention. You know, you're headed towards 0, that your numbers are getting infinitely smaller. But that's something new, I guess, to watch out for. Okay, headed towards 0. So for the two-sided limit, this does not exist. Our two one-sided limits do not match. One doesn't exist. One is headed towards 0. So from both sides, it does not exist. And that actually, so we didn't even necessarily have to find that second limit in order to find this two-sided limit. If you have 1 does not exist, then your two-sided does not exist. Let's make a note of that. If one of the one-sided limits does not exist, then the two-sided limit does not exist. Give you a second to write that down. Okay, let's move on. So next up, looks like this is our final problem. The limit as x approaches 3 of x squared minus 8x plus 15 over x squared minus 2x minus 3. So this is a two-sided limit. Nothing necessarily new here. This is more just a review problem. Make sure that we all remember how, some of our strategies from last week. So with this one, you can't plug in 3. It's going to give you a denominator of 0. You get 9 minus 6 minus 3 would equal 0. So can't use direct substitution. Instead, let's try to factor this. Okay, remember you can factor. You don't always have to go right to that table. So on the top with our numerator, we've got x squared minus 8x plus 15. Let's get a couple x's in there. We can I can do some my best Dora the Explorer impression here. If we have x and x multiplying be x squared, and then we got to multiply to be 15, what numbers go here and here? That's right, -3 and -5. Good job. If we're multiplying to be -3 on the bottom, but adding to be -2, what do we need down here? Yeah, you're right. -3 and +1. That was pretty good, right? So then we have the same factor on top and bottom, x minus 3, x minus 3. Let's get rid of those and go to our direct substitution, plugging in 3 for the x on top and on bottom. Okay, so on top there you got 3 minus 5, 3 plus 1. It's going to be -2 over 4. Make sure you reduce all your fractions and you get -1/2. -1/2. All right, as you're writing that down, I'm going to get the homework ready for you. So we're working on starting the worksheets. Remember that you can start bringing your textbooks back to class, and we'll leave them on the shelf by the windows. As long as you finish the first 2 assignments from this chapter, then we're all done with the books for the year, and we're just working on the worksheets. And so for this assignment, this is assignment number 3, but we're going to worksheet number 1, 1 to 29 odd. Make sure you skip number 19. All the answers for the worksheets are on the back of the assignment list, just like the problems out of the book. And hopefully I will see you all tomorrow. Have a good one.